On January 16, 2021, NASA conducted the hot fire of the core stage for the agency's Space Launch System that will launch the Artemis 1 mission to the Moon. The hot fire is the final test of the Green Run series. The test plan called for the rocket's 4 RS-25 engines to fire for a little more than 8 minutes. This is the same amount of time it will take to send the rocket to space following launch. The team successfully completed the countdown and ignited the engines, but the engines shut down a little more than 1 minute into the hot fire. Teams are now assessing the data to determine what caused the early shutdown and will determine a path forward. In this case, this test was an important step forward to ensure that the core stage of the SLS rocket is ready for the Artemis 1 mission and to carry crew to the future missions. For the test, the 212-foot core stage generated 1.6 million pounds of thrust, while anchored to the B-2 test stand at NASA's Stennis Space Center in Mississippi. Stennis Center has now witnessed the level of power since the testing of Saturn V stage in the 60s. The SLS core stage is an engineering machine that includes not only the largest rocket propellant tanks ever built, but also sophisticated avionics and main propulsion systems. The hot fire test included loading 733,000 gallons of liquid oxygen and liquid hydrogen. Support teams across the Stennis test complex provided high-pressure gases for the test stand, delivered all operational electric power, supplied more than 330,000 gallons of water per minute to protect the test stand flame detector, ensured the structural integrity of the core stage, and captured data needed to evaluate the core stage performance. The Green Run series of 8 tests began on January 2020, when the stage was delivered from NASA's Michoud assembly facility in New Orleans and installed in the B-2 test stand at Stennis. Each test built upon the previous test with increasing complexity to evaluate the stage's sophisticated systems, and the hot fire test that lit up all 4 engines was the final test in the series. The Stennis team renovated the historic B-2 test stand used to test stages for multiple programs, including the Saturn V and the Space Shuttle propulsion system in the 70s. Coming to last run with all 4 RS-25 engines in operation and considering the first evaluations made by NASA, seems that the problems was related to hydraulic system and that this kind of problem would have been ignored in less conservative parameters. Seems that the test parameters were too tight. It's understandable that parameters were too conservative, considering this was the most important and powerful motors test made by NASA in the last 50 years. Engine number 4 was the first indicated for a possible malfunction, but now the problem's origin seems related to auxiliary power system of engine number 2. There is a thrust vector control system, TVC, that gimbals each engine, and there are 2 actuators that generate the force to gimbal each engine. The actuators in the TVC system are powered by core stage auxiliary power units. As planned, the thrust vector control system gimbal the engines to simulate how they move to direct thrust during the rocket ascent. Core stage auxiliary power unit have the goal to supply power to the rocket stage when engines are not available to satisfy this power request. During invaliding, the hydraulic system associated with the core stage's power unit for engine 2, indicated also as E2056, exceeded the preset limits that had been established. As they were programmed to do, the flight computers automatically ended the test. The specific logic that stopped the test is used only for the ground test when the core stage is mounted on B2 test stand at Stennis. If this scenario occurred during a normal real flight, the rocket would have continued the flight using the remaining auxiliary power units to power the transversal control system for the engines. NASA is satisfied of this 8 minutes test anyway. Engines have reached their full power of 109% and 1.6 million pounds of thrust. Now, data analysis is continuing to help the team determine if a second or third test is required. The team can make slight adjustments to the transversal control parameter and prevent an automatic shutdown if they decide to conduct another test with the core stage mounted on B2 test stand.